So I'm working on this Farmtek light pole. I've been asked to have a look at it. These are basically light curtains. They have a whole bunch of infrared LEDs down here. In this case it's got 4 of them because there's a short bar. Top one here is actually a indicator to tell you what's going on with the unit. Whether it's got power and that sort of stuff, battery's flat, that kind of thing. This top LED here was not working, so I was not showing that it was actually powered on. I've ordered some more parts to replace that. It'll be a little while for they to turn up, so I'm not going to show you that right now, but that's just an LED swap. I've just got to take the LED, replace it with a new one. Not that complicated, you can imagine me doing that, can't you? I thought, well, while I've got the opportunity, I've got the thing here, let's hook up to it with my new 4-channel scope and actually do some reverse engineering on how this thing actually works, because I thought it might be interesting. You know, it's a light curtain, it's got 4 infrared LEDs. How does it know that one of them's blocked? So let's have a look at the scope. It's basically doing 4 packets of pulses. Let's just do this on normal triggering again. So that's basically doing this. That's 4 packets, pauses, does another 4 packets, and just keeps repeating that over and over. Alright, so that's what it's actually doing for the pulses. Now what I actually think will happen is on the larger poles, as I think, because they've got, I think they've got 6 or 8 LEDs on those ones. I can't, might be 8. I'm guessing it'll put some more packets in here. So they've actually allowed for being much bigger poles, I think. So I think the spacing there just allows for more emitters in that timing. That timing there between that point and that point there, so one cycle is 853 microseconds. So that's pretty quick. We'll zoom in and we'll see that this is doing basically 12 pulses per cycle. So each LED does 12 pulses, and they're all exactly the same, all do the same kind of pulses, the same pulse dimensions, they're identical pulse wave shapes and that kind of thing. So it's just cycling through each LED doing 12 pulses, and that's basically what it's doing. So I thought it'd be interesting to show that. 4-channel scope, that's why I wanted one. I've also got the XE over here as well, the 2104 XE. I could have done it on that one, but this is, you know, my new scope. Maybe people didn't realise how these things worked. I was curious to see exactly how this thing was configured and how it's set up. You know, what kind of patterns was it using? It didn't have to use this pattern, it could have been something completely different. Could have done one, then the next one, then the next one, the next one. Just individual pulses. Don't know. But this is how it's done. 12 pulses in each LED. Now, the next thing I need to do is try and figure out what wavelength these LEDs are. So you might notice here I've got my pickup tool, because it's got a reed switch here. These are designed to be weatherproof, so there's no external mechanical switch. Basically what it does is it has this turn on ring here, which has got a magnet in it, which one's really rusty. This one's a bit of a mess. I've actually just designed a new one. Part of the problem was that they had one where the ring had gone missing. So they got one of these poles and the ring's been flicked off it and lost, so they can't turn the thing on. I've actually designed a 3D print version of this, but better, so it won't actually fall off the pole. It's got like a strap that comes across the back of the setting. You can still open it up to get it onto the pole, but the strap around the back means it won't actually flick off if it gets hit by something. I've also allowed provision for a screw, so a screw can be put in between the 2 pieces to hold it shut, so it won't actually open up and fall off. I've also changed the shape of the cam on here, because right now it's quite a rectangular cam. Right, it's got this quite hard corners on it, which makes it easy to catch it and knock it. Right, I've designed it so that the switch section here is actually rounded, so if anything does hit it, it's more likely just to glance off it instead of turning the switch, because that does happen sometimes. These are used in dog sports, and the dogs sometimes, if they wrap around the pole as they're coming around the jump, wherever these may be, they can actually knock these with their tail and turn them off. I've seen it happen a few times, so I'm trying to make it so that doesn't happen either. So I've redesigned these, made them better, because, you know, not hard. That's basically a 6mm magnets in there, round magnet. So you can buy those off AliExpress, not a problem at all to get. So basically, instead of having that in place, I've just got my pickup tool here to activate the reed switch, which is over here. So the initial surge of about 30 milliamps, and it drops down quite low. It's hardly any power at all. If I drop the voltage down, it might actually induce a higher current. 5 to 7 milliamps going in. Very little power at all to actually run this thing. I wonder the battery's lost along. So let's look at some reverse engineering side of this. Right, so you've got power coming in, negative, positive. We have the reed switch here. Straight after the reed switch we have some circuitry. So it goes, we've got a smoothing capacitor, we've got a diode that passes through, we have a resistor divider and a couple of transistors. I'm not quite sure what these are, I haven't looked those up, but these wires here, they go along the back of the board and go up to the microcontroller. So I believe these are measuring the input voltage from the batteries. So it's pre-regulation, and I think it's measuring the voltage of the batteries, so it knows what voltage the batteries are at, so it knows when it goes flat. Down here we've got one of the emitter sections, so all we have is a smoothing cap here, switching transistor, and a couple of resistors there. One is obviously a current limiting resistor for the LED. So that's the negative there, and the supply, or the switching from the microcontroller comes on this track down to here. Right, so it's basically a duplication across all of these. These are all the same setup. Here's the voltage regulator, so that's the main power supply section just there. So this regulator here, it's a 5-volt regulator, so it inputs whatever. I think that's about 8.5 volts, the same from the batteries, 9 volts, something like that. So the battery pack supplies with 6 AA cells, so it's about 9 volts or so coming in, and this is a 5-volt regulator, so it's just outputting 5 volts. It's got a smoothing tantalum cap just there for the sake of it. It's a linear technologies device, outputs 5 volts. Another LED section. This I'm not sure what it's doing. That might be programming, because these are programmable to a point, but I'm not quite sure what these are doing here. Now the tracks from the voltage regulator section do come up to here, so it comes up to this one for a start, and yeah, so I think there's something to do with that. Obviously some discrete circuitry for the actual microcontroller. I've got a 20 MHz crystal, a couple of capacitors for loading on the crystal. All that there is just the oscillator section, that's all that's doing. Smoothing cap, and then we've got some more resistors and stuff here. So another infra LED section, exactly the same as the others. Here we have another switching transistor, and another one here. So these two here are switching this dual colour LED. So that resistor there is obviously for the switching as well. So that LED has got, I think it was red that side, green this side, I think it was. And it's got a common positive. Well, they're individual LEDs in one package basically. So that's anode, cathode, cathode. So diagonally opposed. But it's basically two individual LEDs. So if you really wanted to, you could actually swap this out for individual LEDs and restore it. But I've actually ordered a new part, so I'll be replacing the actual LED because it's dead. Measure the voltages across here, and they're there. It just doesn't actually light up. It's fried itself for some reason. Simple enough. I mean, it's really simple circuitry. As you saw, you know, the pulses and stuff is just modulated, so it can detect itself from the actual receiver unit. So this is just a sender. So what's under here? I don't know. I think it's a PIC. I know they use PIC in the other devices, so it's probably a PIC as well. It's what they're tending to use. I don't know if someone wants to try and figure out the pinout from that. Here you go. Try and get the light on it. See the various pinouts. Even try and get in focus at the same time. Alright, different lighting. There you go. Give it a chance to see it all. And from the back, nice to see there. Just a few traces along the back there. Nothing too exciting. It's a pretty simple unit. The receivers are actually much more interesting. There's a lot more going on those because they've got a LoRa module on them and that sort of stuff. And these are 915 MHz LoRa for this country. Other countries might be different frequencies. So it's going to be upside down, but let's just try and figure out what wavelength these are. So I'll put this in front of the LED, the infrared LED, and we'll try and figure out what wavelengths these are. We'll look at the power readings and we'll see which one's got the highest readings as we go through each one. Right, let's try this again. This is a bit of a hard thing to get right because any off angle is affecting the readings, so I've got to try and hold everything dead steady as I do this. Try to. So I can get this any better in now. Can I get the LED basically right into the emitter of that? Maybe I can. Let's try this again. Yeah, just trying to get the thing really close to it is really hard. 980 seemed higher. 850. Give it going again. 850. Sort of 4,000 or 4 microwatts is like the highest I've seen. 850, 980. It's closer to 5. Yeah, 5.2 or so does then. Moving it around. Yeah, so I think 980 nanometers is the wavelength of these infrared LEDs, because that's where the peak is. Don't forget to comment down below if you've got anything to say about these things or anything in infrared in general. Like, if you've got experience doing infrared stuff, then please comment down below as well and let me know, what your opinions on how this is working. I haven't done much with the infrared. In fact, I've done almost nothing with infrared. So I thought I'd find this interesting as well for myself, my own interest. Please make sure you comment down below and give us a thumbs up if you like the video. Subscribe if you're not already subscribed. Click like, subscribe, just like it says on the desk. Do what the desk says. Desk is always right. Catch you next one. Bye.